In the last video, we did the forward button. When you click the forward button, the train moves forward. We also did the stop button. If you click the stop button, the train stops. We then did the reverse button. If you click the reverse button, the train goes backward. So these are the three buttons we created and added the functionalities. In this chapter, I've extended the single track into two tracks, and both the tracks are connected independently to the Node MCU chip, and they can be controlled independently. Both the tracks are also connected together through a double crossover, and that will allow the train to move from one train to another. The double crossover is also controlled by Node MCU. The Node MCU controls both the tracks and also the double crossover. I've also extended the dashboard to include both the tracks. Now, both the tracks can be controlled independently. I've also added a button for the double crossover. Clicking the button will allow the train to move from one track to another. And finally, I put an emergency stop that will stop both the train in both the tracks. And that's the setup. And now let's see how it is actually working. So I'm clicking the forward button. The train starts at the speed of 200 and it keeps increasing slowly. And there is a target speed that is actually set, which is 800. The train slowly increases all the way up to 800, and once it reaches the target speed, it will not increase further. And now we can stop the train, it stops. When you reverse the train, it does exactly the same. It starts with the speed of 200 and slowly increases all the way up to target speed, which in this case is 800. And once it reaches the speed, it doesn't increase the speed anymore. And now you can see the double crossover in action. When I click the button once, the crossover is activated and the train goes into the inner track. Clicking it again, the crossover goes to the original position and the train remains there. I'm clicking it again. Now it goes to the outer track and stays there. The stop button will stop the train again. And now you can see I'm reducing the target speed, changing the target speed. And what that will do is it will not allow the train to go more than that speed. So now the train is started, it's going and reaching up the target speed. And once it reaches the target speed, that's it, it stops. And finally, the emergency button stops both the train. And as far as the setup is concerned, it's very similar to the last time. I have a 12-volt DC, which acts as a power bus, and then a breadboard, which houses the Node MCU, which is at the heart of all the automation. The Node MCU also has an ESP8266 Wi-Fi chip, and because of that, I'm able to control everything through a web browser. I also have now two motor drivers. One motor driver controls the track, inner track and outer track, and the other motor driver controls the double crossover. All the programming is written in the Node MCU, which controls the track, it controls the power. It also has some smart features, especially when the train is moving between the tracks. There needs to be some safety mechanism put in place and some smart features. So that all is inside the Node MCU chip, and in future I might share some code on how that is actually being done. And that's it for the chapter 2. And in the next series, I'm planning to do some sensors, allowing us to identify where the train is, what the train is doing, and how things are connected. So that's it for the chapter 2.